Dear viewers, hello and welcome to another session of our lecture series. Today, we will discuss the physical properties of soil with special reference to soil texture and soil structure. Soil is a complex mixture of mineral particles, organic matter, water and air. In addition, soil also has a biological component comprising of flora and fauna. These include bacteria, cyanobacteria, fungi, algae, protozoa, rotifers, arthropods, mollusks, and a host of other organisms. Among the physical properties of soil, soil texture and soil structure are of fundamental importance. Let's first talk about the soil texture. Soil texture is the percentage of the mineral matter by weight in each size class or size group without considering their chemical composition and other properties. These groups of soil particles are known as soil separates. Generally, a soil is composed of more than one soil separate. The three main and basic soil separates are sand, silt, and clay. The soil separates are defined in terms of particle diameter in millimeters. The size limit of these soil separates have been established by various organizations. Thus, there are various systems of naming these soil separates. These systems are: number 1, the American system developed by USDA. Second, the British system or English system known as BSI. Third, the international system which is developed by ISSS. And the fourth type is the European system. According to USDA or the American system, different soil separates have the following dimensions: clay less than 0.002 millimeters, silt 0.002 to 0.05 mm, very fine sand having the diameter of 0.05 to 0.1 mm, fine sand with the dimensions ranging between 0.10 to 0.25, medium sand having the size range between 0.25 to 0.5, coarse sand between 0.5 to 1 mm, and the very coarse sand having the dimensions of 1 to 2 millimeter diameter. According to the British system or BSI, dimensions of the different soil separates are: clay having less than 0.002 mm diameter, fine silt with 0.002 to 0.01 mm, medium silt with 0.01 to 0.04 mm diameter, coarse silt with 0.04 to 0.06 mm, fine sand with 0.06 to 0.2, medium sand with 0.2 to 1 mm, and coarse sand having the diameter of 1 to 2 millimeters. According to the International System or ISSS, the dimensions of various soil separates are: clay again having less than 0.002 mm diameter, silt with 0.002 to 0.02 mm, fine sand with 0.02 to 0.2 mm, coarse sand with 0.2 to 2 mm diameter. According to the European system, particle size range of various soil separates is fine clay with less than 0.0002 mm diameter, medium clay ranging between 0.0002 to 0.0006 mm diameter, coarse clay with 0.0006 to 0.002 mm diameter, fine silt with 0.002 to 0.006 mm diameter. Similarly, medium silt is having the diameter of 0.006 to 0.02 mm. Coarse silt ranging between 0.02 to 0.06 mm. Fine sand between 0.06 to 0.20. Medium sand with 0.2 to 0.6 mm diameter, and the coarse sand having a diameter ranging between 0.6 to 2 mm. Larger particles with more than 2 mm diameter are not included in soil textural determination. The size limit of these larger particles includes gravel between 2 to 4 mm, pebbles having a diameter of 4 to 64 mm, cobbles with 64 to 256 mm, and boulders having a diameter of more than 256 mm. Based on different relative proportions of soil separates, soils are classified into various textural classes. These textural classes are depicted in soil structure triangle, where the varying combinations of sand, silt and clay result in different textures. For example, a soil which is composed of more than 80% particles of sand is called as sandy soil, while as a soil comprising predominantly of clay particles is called as the clay soil. A soil comprising of sand, clay and silt in the 40%, 20% and 40% proportion respectively is called as a loam. Soil with a 50% fraction of sand, 30% of clay and 20% of silt is called as sandy clay loam. Various soil textures arise by different proportions of the mineral particles, and these textures can be read from the soil texture triangle. There is another type of soil texture classification, according to which soil textures are of three types. 1. Heavy or fine texture. 2. Medium texture. And 3. Coarse or light texture. A soil which is dominated by clay particles is called as fine or heavy textured soil, while as a soil having sandy particles as the dominant constituents is called as coarse or light textured soil. Medium textured soils are the ones where the three mineral particles are present in about equal proportions. Soil texture is not influenced or changed by crop or soil management practices because it does not alter the proportion of soil separates in a soil. The soil texture is the primary soil property which influences other physical and chemical properties of soil. The proportion of clay and sand particles in a soil determine many soil properties. These include drainage, porosity, water holding capacity, bulk density, cation exchange capacity, leaching and pH buffering capacity, soil structure, erodibility and organic matter content. When we talk about drainage, the soil texture determines the rate at which water can percolate or drain through a saturated soil. Sandy soils offer a free and rapid movement of water than do the clay soil. Another soil property is the porosity. It refers to the amount of spaces or gaps between the soil particles. Porosity also depends on texture. Fine or clay soils have smaller but numerous pores called as micropores, as compared to the sandy soils which have less number of larger pores called as macropores. Thus, the porosity of fine soils is more than the coarse ones. Water holding capacity of soils is also dependent on their texture and organic matter. Clay soils have a higher water holding capacity than the sandy soils because they have larger porosity. In addition, water binds to the clay particles of soil, thus enhancing its water holding capacity. One more property of soil is the bulk density, which refers to the ratio of dry weight per unit volume of a soil. The property of bulk density of soils depends on their texture and organic matter. This bulk density is inversely proportional to the porosity. That means higher the porosity of a soil, greater will be its volume and lower will be its bulk density. Thus, the sandy soils which have lower porosity have higher bulk density than the clay soils which have higher porosity and thus the lower bulk density than sandy soils. Another important soil property is the cation exchange capacity. The cation exchange capacity of a soil refers to its capacity or ability to bind or hold the cations. This property of soil depends on the texture, that is the proportion of clay particles, and organic matter content of a soil. Clay particles have net negative charge and thus a lot of cations bind to the clay particles. The sand particles do not offer such negative sites for the cations to bind. Thus, the nutritional status and cation exchange capacity of a soil can be influenced by the proportion of clay particles. Therefore, we can say that the clay soils have a high cation exchange capacity than the sandy soils. One more physical property of soil is the leaching and pH buffering capacity. Soil texture also determines the rate of leaching of cations such as magnesium and potassium. In a soil which is more in sandy soil than in the clay soil because of high CEC or cation exchange capacity in clay soils than the sandy soils. Besides, clay and organic matter content in a soil also determine the buffering capacity of a soil, that is, the resisting the pH change. The soil texture also influences another soil property, that is the soil structure. Generally, the sandy soils are structureless, while as in other textures, particles aggregate to form varied structures. The soil texture also influences the soil erodibility, that is, the susceptibility to erosion. A soil with high proportion of clay and silt has more erodibility than the sandy soil under similar environmental conditions. The soil texture also influences the level of organic matter in different soils. The sandy soils show a faster decomposition of organic matter content than the clay soils under similar environmental conditions. This is because of the greater availability of oxygen for decomposition in light textured sandy soils. After discussing the soil texture, we now come to the second part of today's lecture, that is where we will discuss the soil structure. Soil structure is an important physical property of soil. The soil particles such as sand, clay, silt and organic matter in a soil combine with one another in different ways to form larger particles of different shapes and sizes. These larger particles of different sizes and shapes are called as soil aggregates. Soil aggregates serve as the structural units of the soil. The soil structure is actually the arrangement of soil particles into the soil aggregates. Thus, precisely speaking, arrangement of soil particles into aggregates of various sizes and shapes is called as the soil structure. There are 8 primary types of soil structures, which are blocky, crump, platy, prismatic, columnar, granular and massive. In blocky type, the soil aggregates or structural units are block-like or polyhedral and consist of 6 flat or somewhat rounded surfaces. The units in blocky structure are more or less equidimensional. The blocky structure is said to be angular blocky if the faces intersect at sharp angles, and it's described as subangular blocky if the faces are a mixture of plane and rounded faces with corners mostly presenting a rounded appearance. In second type, that is the crump structure, the aggregates are small, porous and are weakly held together. In platy soil structure, the aggregates or units are flat and plate-like. These units are generally oriented horizontally with some degree of overlap, which causes slow permeability. A special form of platy structure called as the lenticular platy structure is recognized, where the plates are thick in the middle and thinner towards the edges. In the fourth type, that is the prismatic structure, the units are vertically longer with flat or rounded vertical faces. The vertices of the units may be angular or sub-rounded. The tops of the prismatic units are a bit indistinct and normally flat. Another type of soil structure is the columnar. The units in this structure are similar to that of prismatic and have vertically long, flat or somewhat rounded faces. The tops of columns in comparison to the prism are very distinct and normally rounded. In granular soil structure, the units are more or less spherical or polyhedral, bounded by irregular or curved faces which are no way the casts of the adjoining beds. In case of the single grain structure, the soil is structureless. Soil particles exist as individual grains and do not form aggregates. Single grain soils are best exemplified by sandy soils where particles do not aggregate. The last type of soil structure is the massive. It's also structureless, without an apparent structure. The soil particles are joined together into huge uniform masses. An important aspect of soil structure is the grades of soil structure. Grade describes the distinctness of units. It also describes the ease of separation of units and the strength of units when the soil is handled. There are normally 3 grades of soil structure, and these are weak, moderate and strong. In weak structure, the units in the soil are hardly observable. When the soil is gently disturbed, the soil material breaks into a mixture of whole and broken units and much material which is not in units. In moderate structure, the units are evident and observable in the undisturbed soil. When the soil is disturbed, the soil material breaks into a mixture consisting mostly of whole units, less of the broken units and material which is not in units. In case of the strong graded structure, the units are very distinct in the undisturbed soil. On disturbing this soil, the units separate very easily and cleanly into whole units. Another important property or aspect of the soil structure is the classes of soil structure. Class of structure refers to the average size of individual beds or aggregates. There are 5 classes of structure which encompass all types of soil structure. The size limit of the classes differs according to the shape of the units. These classes include very fine or very thin, thin, moderate, coarse or thick, and very thick or very coarse. The size range of different classes for different structures can be seen in the table. Soil structure can be changed by crop and land management practices. The soil structure also influences other soil properties such as porosity, water holding capacity, air and water movement inside the soil, bulk density and many other similar properties. Dear viewers, with this we come to the end of today's lecture, in which we thoroughly discussed 2 important physical properties of soil, that is the soil texture and soil structure. We hope you liked the lecture well. Thank you and goodbye.